Okay, good afternoon everybody. My name's Andrew Woodhouse, and just a bit of background about myself. I actually studied product design engineering at the Art School and Glasgow University before working for a number of design consultancies, and I'm now teaching design at Strathclyde. So I'm just going to give you a bit of an overview about our department and different ways that you can engage with us and what we could perhaps contribute to your organisation. So the University of Strathclyde is the third biggest university in Scotland, and the Faculty of Engineering is the biggest faculty of engineering in Scotland. And I think we've got over 3,000 undergraduate students. So we sit as part of the engineering faculty, and the department is design, manufacture and engineering management. And it's a slightly unusual department. We've got a very long title, and that's because we do cover a number of different areas of expertise. So it's slightly different from your traditional, architecture or mechanical engineering. And I'll go into a bit of depth about those different areas in the presentation. So we like to identify the skills that we have in the department through these three different categories: create, make and manage. And those align with create is the design aspect, make is to do with manufacture and production, and management is the business aspects. So we've got academics from all of these different areas teaching courses to our students, and we've got undergraduate degrees that are composites of those different topics. So first, the design aspect, create. Well, we've already heard a bit from Joe about how design and innovation can drive new product development. So we've just got an example from the Dyson vacuum cleaner here. Now obviously the cyclone technology was a great differentiator for separating the dust, but also in terms of usability, ergonomics and things of that nature. These drive product configurations and new variations of old designs. So that very much is a key part of our design process. When it comes to make, manufacture, again that's integral. We've got an example again from Apple here, and Apple are renowned for having beautiful looking products, but they also work well. So we've got this stand here where the screen is mounted on that. It requires an engineer to think about the material that's used, where the centre of gravity of the screen will lie, in order to make that as thin and elegant as possible to make a really pleasing design. Similarly with a laptop, again, when it comes to manufacturing and assembly, getting so many components into such a small space envelope requires a lot of ingenuity, a lot of design thinking. And then finally, production. Complex products like aeroplanes consist of thousands and thousands of different parts that are manufactured in multiple places all across the world. So supply chain management, business processes, logistics, again, these are key aspects of product development and things that we teach as part of our undergraduate degrees. Here are a list of all of the things that we do teach. As you can see, we've got undergraduate and postgraduate courses. I'm not going to go through all of them, but what I'm going to do is just illustrate the 4 undergraduate courses so that you can see the types of things that we teach and the kind of background that our academic staff have got. The first one is product design engineering, and that is a combination of engineering design with softer industrial design type of skills. And the example I've got here is a car headlamp. One of our graduates recently went to work for Jaguar Land Rover, and his first job was looking after the design of a headlamp. Okay, now obviously whenever you're designing a product or a part of a product like this, you need to think about the aesthetics. A car's very heavily styled. It's a key aspect of its a key aspect of the car's sellability, but also there's a lot of engineering to the lamp itself in terms of the materials that the cover's made of, the electrical requirements, the lamp itself, all of these different aspects. So there's a real combination between the two different sides. We've got a course called Product Design and Innovation, and it's a bit softer than the product design engineering degree. There are more business and strategy elements to it, more user-centered design classes, and a couple of our PDI graduates from a few years ago actually set up their own business, are now selling this high-end luggage for business travellers. So they had the design skills and the business skills in order to go off, secure funding and get their business going. We've got a sports engineering degree, where it's a slightly unusual combination of design engineering with sports science. It's partly taught in conjunction with our bioengineering department. And the idea is that students have a good understanding of the human body so they can design sports products. Obviously, these are used in conjunction with the human body. We've got the example of the British cycling team here. You can see the amount of equipment that's used by these cyclists, and small improvements can make a big difference in terms of positions and medals. And a number of our graduates have gone to work for Adidas over the years. And finally, production and engineering management. I've got an example from the renewables sector here, which of course we hope is going to be a major part of the economy going forward in Scotland. But as I said, dealing with supply chains, looking at organisational structures, all of these kind of things is a core part of that degree. A bit about the department itself, the kind of environment that we have. We've got a lot of research that goes on. We've got an advanced forming research centre, which is an industrial-based, an industrial-linked research institute. We've got a research suite within the department itself with a number of research staff. We've got digital design manufacturing capabilities. We've got a very collaborative team-based approach to education and design. We've got a large open space studio where a lot of teamwork and project work takes place, as well as all of the traditional engineering and workshop facilities you would expect from an engineering department. So your laptop seems to have seized up. Oh, that's it. Okay, so I just put this slide together for the types of collaboration that organisations can engage in with our department, and I'm just going to give you brief examples of each of these as part of the presentation. We're going from very short interventions, as in a summer placement student for a couple of months, right through to a long-term research collaboration, which could typically last for a number of years and require significant investment, where the university and the company are trying to create new knowledge. So the first thing I was going to mention was individual design projects. So all of our 4th and 5th year students undertake a project that runs from October through to May, and these are ideas that they can come up with themselves, or they can do so in conjunction with a company. And at the end of that process, we have a showcase where we display the best of the work, and it usually takes place in the Lighthouse, the Centre for Design and Architecture in Glasgow. And the students can then show off what they've done during the course of the year. Here's an example of a project a student did. It's a safety aid for divers. It releases a capsule to provide a marker for where they are. And typically in a project, the student will go off and do research about the market, the demand for their kind of product. They'll try and correlate between user needs and product functionality using matrices such as this. They'll investigate technologies and mechanisms that might be appropriate to their design. They'll start doing sketch work, coming up with ideas. They'll do test work, building prototypes, and trying to see how it performs in the environment of use. And we have a lot of prototyping capabilities to build realistic models that they can actually test. And then use computer-aided design to visualize how the design is going to look, and also how it's going to work and be manufactured. And towards the end of the process, looking at costing and retail, and there's the finished design there. And another example here of a hiking stove, so that you see some of the similar types of things emerging here, looking at the market, trying to identify gaps where their product could sit, doing sketch work, coming up with ideas. Typically a design process, we're going from a large number of concepts and funneling that down to a particular idea for further development. Layout drawings, where we start to understand product functionality and look at variations therein. and then starting to embody the concept and doing engineering analysis. So as well as being able to do the industrial design work, our students can look at how a product's being stressed during its working life, the kind of forces it's exposed to, what materials it has to be made of, how the geometry can be adjusted to cope with those kind of demands. And there's the finished design there. Okay, another way that we work with companies is through industrial team projects. I actually coordinate this class. So during the summer, I think we arranged 28 projects with different companies, from individuals to multinationals. And these are team projects that run from October through to May, again, so they follow the academic calendar. And we really put the onus on the students to run these projects. We give them a number of lectures on project management, and we ask them to try and conduct the projects in a professional kind of way. And you know, they use things like Gantt charts, meeting minutes, project planning, and so on to try and do that. And just a couple of quick examples. This one is the redesign of a workstation in a production line, where the students went out and had a look at what was actually taking place. They began to understand systematically how the workstation was organised. They began to come up with new ideas for how it could be changed or altered. And we've got sketch work there. Model making again to try and visualise this in 3 dimensions. Evaluation matrices to understand strengths and weaknesses of different concepts. Further embodiment, and final distribution layout, final design. And a second example, this one was quite interesting. It was using bamboo as a structural material for an organisation called Engineers Without Borders. And similar kind of process, you know, coming up with different concepts, quick models to explore variations, looking at the engineering and configuration of the design, trying to do mechanical testing as appropriate for their particular product, starting to establish a design, and then refining a prototype. And there's the student team there. When I just included this slide, we worked with a company called Funky Moose for a number of years. This is a company that design cones that allow school kids to run between them in a kind of game. It can be reconfigured for different exercises. And we did a number of projects with them, and he appeared on, not the Seas of Dragon's Den just there, the one before. I think he actually managed to secure funding from one of the bad guys. I can't remember which one it was, but he did well anyway. So. But the students really contributed to where he got to in that case. Now, research collaboration, there's a lot of research goes on in the department, and we can engage medium to long term. And as I said, we're trying to develop new knowledge in that kind of instance. I've just picked out a couple of the large examples in this case. But again, it's because the department is quite broad-based, we talk about ourselves as engaging in total engineering. So we're doing research in product design and development. That's the kind of area that I sit in. I'm actually looking at interface design at the moment, but we look at manufacturing technologies and engineering management. So quite broad. I mentioned the AFRC. This is a new research facility. It's actually based in Shannon, so it's a separate building. And it was actually, it's been developed in conjunction with a number of industrial partners, so Boeing, Rolls-Royce, a number of others have invested a significant amount of money in this facility, and they help drive the research agenda in that particular establishment. So this model is actually being used by the university for a new technology and innovation centre, which you may have heard of. And the AFRC is primarily concerned with forming and forging of metal components for aircraft and high specification design. The Euro VIP project is another very large project, 1.8 million euros, with 17 partners across Europe, both academic and industrial, and that's looking at using different computer systems and information management systems to support collaborative working. So again, which could be relevant to organisations which have to work in a distributed way due to geographical reasons. Knowledge transfer partnerships were mentioned earlier. This is a way for companies to engage with the university via an associate who is appointed for 1 to 3 years, typically 2, and they're part funded by a grant and part funded by the company, and they're assigned an academic supervisor as well as a mentor in the company. And DMEM, I think, has had more KTPs than any other department in Scotland. I think we're in the 20s. I'm involved with several myself, but we've got a list of some of the companies that we've worked with in the past year. Yes, I've been working with Holly and Kirkwood actually to develop a knowledge management system, so reusing their design knowledge and information from past projects to make sure that they apply that going forward whenever they're undertaking a new design challenge. We've just got a quick example here from Scott Oiler. We've done a number of KTPs with Scott Oiler. They basically design systems to oil the chains of motorbikes, and we've had successful KTPs looking to try and embed enhanced design thinking and design processes into their organisation. Consultancy we do as well, so we can provide bespoke consultancy services in a number of different academic areas. I've got an example again of one of the pieces of work that I've done. This was last summer, and I was looking at designing a golf training aid for a client who came in, and he managed to secure some funding. And it was looking at mechanism design, design for manufacture, and using some of our rapid prototyping facilities to create a model of the idea that he had and trying to take it towards a more realistic product. And we're actually continuing to engage with this client. We've got a team of our product design and innovation students looking at the marketing and packaging of his product as well, so providing an overall package of his product that he can then take forward, hopefully. In terms of training, again, there's a number of different courses that we run in the department. We've got a Lean Six Sigma course, which is very much management orientated. There's a number of other management related courses. We're looking at trying to develop some design related courses as well to do with innovation and that kind of thing. Now, in terms of our facilities, DMEM has got quite a nice spread of facilities, state-of-the-art equipment that is available to industrial clients. Now, the main thing is our digital design and manufacture studio. This is a space where we've got high-end CAD workstations running state-of-the-art software, but we also have, just partitioned off of that room, a range of rapid prototyping facilities. So we've got an object printer, which can very quickly produce highly accurate 3D parts, a 3D printer which can produce full colour models very quickly, 3 and 4 axis CNC routers, laser cutters, engravers, vacuum forming, a lot of different manufacturing processes. So depending on what type of prototype you wanted to make, we've got different pieces of kit that can make the right type of model for you. We also have what we call reverse engineering capabilities. So we've got 3D scanners. We've done work with medics and archaeologists in the past to scan in, historical artifacts or bones and all kinds of different things. There's lots of things we can do on that side of it, and a stereoscopic projector, so that if we create a CAD model, we can use the stereoscopic projector to create a 3D animation. You put on the goggles and the model kind of comes out the screen and takes on an extra level of realism. So it's a nice facility that we are quite proud of. And summer placements was one of the first things I mentioned. This is a very quick way that we can establish a connection with a company with a view to possibly moving forward in the future. And that's simply during their summer break, which is June to September. They might just work for a portion of that. But the students can receive academic credit for a placement, providing it's aligned with their course. We've just got an example here from Jennifer Campbell. She was a sports engineer. She went to work for a company called Innovate, who sell trail running shoes, and she was working on the women's range, and she actually went to work for Adidas last summer. So yeah, that was a productive placement. And I think we're going to talk a bit more about funding avenues shortly, but just wanted to highlight a few. Some of these were mentioned, innovation voucher schemes. We've got a scheme called Strathclyde Links, which again is another 5K scheme to allow SMEs to access an academic quickly. and then begin that process of engagement. Strathclyde MedTech, for those who are in the medical field, I'm actually in the process of accessing this funding at the moment. I've been talking to a local company who are in bioscience, a biomed company. And it's, again, in that instance, what we are looking to do is the company's got an idea for a product. They wanted to talk to us about how they can, do conceptualization and work towards a prototype. So the initial 5K is enough for us to kind of scope the project, understand what the main requirements are, plan out a development process, and work towards a design specification. And then there are other pots of money, things like Bridging the Gap and various other schemes that we can certainly assist companies in looking for. One final thing I wanted to mention before I finish is that we are interested in design creativity very much. It's one of my research topics, and I'm actually helping to organise a conference this year that's going to take place in Glasgow, along with a number of my colleagues. So it's primarily aimed at academics across the world who are doing research in design creativity, but we also welcome industrial delegates. So if any of you were interested in attending, we'd be more than happy to see you there. You can find out more information on the website. So just to conclude, our department is certainly a very industry-facing department. We've got a lot of links with a lot of different organisations, and these range from very short interventions to long-term engagements. Our department is interested in total engineering with expertise at all phases of the design process, and we're always happy to talk to anybody who is interested in talking to us. So thanks very much.